everybody. My name is Justin Richer. I'm a consultant. I'm based here in Boston, so I'm absolutely thrilled to have y'all here in town. This is great. And I'm here today to talk about OAuth2. And this is going to be a talk that is about OAuth2, but I'm not going to spend time telling you how OAuth works. That's a good summary right there. If you're interested in that, I heard that this is a pretty decent book on the topic, and if anybody wants to talk to me after, I have 4 free electronic copies of that to give away, plus a discount code that my publisher gave me. Come grab me after the talk for one of those. And I'm not here to rant about the standards process that gave us OAuth2. I gave that talk a couple of years ago. You can find that talk up on YouTube, and you get to learn about all of the wonderful characters that you meet in the standards world. I'm also not here to make sort of vague predictions about where the world is going to go, and I am absolutely not here to tell you how the blockchain is going to solve all of your identity and security problems. I am here, however, to talk about OAuth2 and all of the things that can go wrong with it, because it is absolutely everywhere in the world, and when something is that widely dispersed, there's a lot of things that can go wrong. So you might be wondering, am I going to declare that OAuth is dead? We've got a long history of that here at this conference, but quite frankly, it would be really ridiculous for me to do that today because it is everywhere on the internet, from APIs to mobile apps to websites. Everything is using OAuth2 all over the place. But like I said, when things get used all over the place, stuff can go wrong. And there's a lot of stuff that's gone wrong really kind of spectacularly. And that's what I'm here to talk about today, because I think there's a lot of stuff that can really have been done better with sort of the hindsight applied of what we've learned over the last few years. But for all of the nervous CISOs here in the room, I'm here to tell you, it's not that bad. Really. There's a lot of good that you can do with OAuth. There's a lot of things that can be built securely and deployed securely with this protocol. But even though it's not that bad, I do think that we can do better. All right, so to understand how we got to where we are today and what we have today, we have to understand where we came from and sort of the world that OAuth2 grew up in. Back in the day, everything was built with shared secrets, passing passwords to APIs. A couple of companies came up with some proprietary magical boxes to solve that problem a little bit better, and the community ensconced that pattern into the OAuth1 protocol. And this was a really good protocol. People used it all over the place, but one of the interesting things about it is that it never really got rid of the shared secrets. It just automated them in a really interesting way. Now, that is definitely a good thing to have automated all of those shared secrets. It got rid of a lot of the problems around sharing passwords, and that's really great, but fundamentally, it never really got rid of some of the underlying issues about a shared secret-based system. One of the biggest problems with OAuth1 was it had a convoluted HTTP-based signature method that a lot of people really got wrong. And it was just a really, really huge impediment for developers to get this thing right. But one of the biggest pushbacks of OAuth1 at the time was, why would I ever change? What I have works perfectly fine. I don't mind chucking user passwords around. I'm just going to keep doing that. Even so, it did take off a little bit slowly, then gain momentum, and it was really good. But you got to remember, though, that when you make security too hard to apply, people come with creative workarounds to your security systems. And this is inevitable because functionality trumps security every single time. Never, never the other way around. So the community decided that we wanted to move on from the OAuth1 protocol and come up with something better. We didn't move straight to OAuth2. We actually took a stop in the sandwich aisle for the RAP protocol, which kind of took the OAuth protocol and its ideas and concepts and simplified it. And it was the RAP protocol, that was really built up into the OAuth2 protocol. And then to understand OAuth2, you need to understand that it is a child of its times. 2010 to 2012, when the protocol was really being worked on and ratified, was a very, very different world from what we have today, isn't it? It's 2018. The internet, that's ages in internet time. What's some of the stuff that's happened? Well, JSON has taken over all kinds of APIs everywhere. But at the time, it was all form-based parameters. JSON was a thing for responses, but not really requests, and that's why OAuth has this weird form-based post and sometimes form-based response and the query parameters. And if we were building it today, it would be JSON in, JSON out, no question. That's just how you do things today. And that's something that, well, we didn't predict very well at the time. We also had a model with OAuth2 that everything was about one computer talking to another computer. And your computer was probably, and if you're a big provider up in a data center, though most of us, this was probably a little bit more accurate depiction of what our server systems looked like. But there's this notion of that my computer is going to talk to your computer and they're going to connect, and that's how OAuth is going to work. But that's not how it works today, is it? We've got container-based systems, microservices, API gateways, and it completely changes how the security model works. This assumption of who gets to know what secret, who gets to move which piece of data around is totally different from how we were building things 8 years ago or even 5 years ago. It's a very, very different world to deploy into, because now everything is cloud-based. And if you're one of the big providers, this is probably what your cloud system looks like, but let's be honest, this is probably what most of our cloud systems look like today for most of us here in the room. So, mobile applications, absolutely enormous, really weren't that big of a deal back then. When OAuth1 came out, it was totally not a thing. But when OAuth2 came out, we at least said, like, oh, mobile apps might happen. Probably, yeah, we'll have a thing in there for that. But they weren't really fully addressed. Not in the way that a security protocol being built today from scratch with what we know for how the world is today would have done so. And so what we have ended up with all of this changing world, people are still using OAuth in all of these spaces. So if you were here for George's talk last, that giant list of standards, that's what OAuth is today. It's no longer really just one standard. It's a family of standards that get composed together in different and interesting ways to solve different problems. And this is kind of like the time that I told my partner that we're having a couple friends over, so let's just have a simple salad for dinner. And this is a picture of half of the ingredients on my table that got put out for this nice simple salad. It can make for a really great salad if you know exactly what you want in and what kind of goes together, but how are you supposed to make a choice with all of these different options that you can snap together? Because it turns out that people don't want just a giant pile of parts for most use cases, because it takes a lot of effort and a lot of skill to properly put those parts together. What people want is a way to is an understanding of how to bring those parts together into a model that can build something that people can use, right? So we started to build those models that were not included in the OAuth2 protocol itself. There was no definition of what a client was in OAuth2. It was a thing, but does it have a name? Does it have URLs? Does it have a home page? What does any of that even mean? We had to define all of that in a structured way for dynamic client registration, which is an RFC that came later. There was also no model of what an access token means. Does it represent a user and a client and a scope and an expiration, or are there other bits and pieces? Does it represent a targeted resource? There's no real mention of what an access token represents in the OAuth protocol, but when we came up with structured token formats, which is JOT, the first one, or query-based systems, token introspection, the second number up there, we had to come up with a way to say this is what a token means. OpenID Connect came along and came up with some really great ways to do more advanced client authentication mechanisms. And unfortunately, the OAuth2 spec itself says clients can authenticate, I guess. Sure, maybe there's a secret, I don't know. So OpenID Connect had to create a structure that it could then build on, which is then bolted onto OAuth2. And you can see this in a lot of implementations today. A lot of systems use these models from other specifications in their implementations. I'm not even going to get into all of the details of discovery because it's way bigger when you go to look at it than you ever think it is. But there's some interesting work that's being done now to try and solve the discovery problem. So people want models and instructions, but they also don't want something that just says, yeah, there are some parts, and here's a, just do it. Just, come up with the final solution and you'll be fine. Because engineers don't build things like this, right? OAuth is also flexible enough that there have been all sorts of interesting extensions to it, including people basically trying to reinvent WS Trust and put it underneath the OAuth umbrella. OAuth's flexibility is one of its greatest strengths, but it's also been one of the community's greatest weaknesses. Because this layer of abstraction that was held onto by the OAuth working group is a little bit too much in a lot of places. Case in point, there's a lot of stuff that got in there as an abstraction and extension point that we thought was going to be a good idea, but ended up not really working in reality. So for example, then this is a tiny one. You get this expires in claim when you get back an OAuth access token, and it tells you this is the number of seconds that the token's going to expire in. Makes sense, seems like it would be useful. Developers can use this to go and proactively grab new tokens. Turns out that OAuth client developers don't care. They don't do that because they need to be prepared for their token to stop working at any point anyway. So why are they going to go have some thread that's checking this and go off in the future and like, I'm going to just go get a new token just in case? Almost nobody does this. I know a couple of Germans that are doing this, but other than that, nothing, right? And then there's the whole matter of token presentation. In the original OAuth spec, we were planning to have two different token types, so that's why we have this token type field. There were going to be bearer tokens, but they're going to be MAC tokens. The MAC tokens got dropped on the floor. That spec never materialized, nor did any other tokens that were built on top of that. But we now have other token presentation mechanisms, including MTLS and token binding. And the thing about token binding is that it still uses that token type bearer, because now we have this point of extension that's baked into the OAuth protocol that everybody expects to just be token type bearer. Nobody really has switching code in there. They say, if it's not bearer, then throw an error, because I don't know what's going on. By the way, Brian is giving a talk next about token binding. He's way more into this than I am. So if you want to know more about this, Brian is the guy to come talk to about that. So now let's talk about the front channel. The front channel is one of the most interesting innovations of OAuth-style protocols because it allows the user to be involved in the entire security process. That's a really wonderful thing because we can do this without having the user be, chucking their credentials back between servers. But the problem is that it breaks up the connections between different systems, so you lose a lot of the assurances that regular HTTP has built in. But it also relies on this weird thing called a redirect URI. Redirect URI is woefully under-specified in the OAuth2 protocol because I was just talking with somebody yesterday about this because it just says match it, and it doesn't really say what matching means. You could do subdomains, wildcards, all kinds of stuff like that. It's really kind of whatever you feel like matching means to you today. This is at the core of a lot of breaches. There are documented breaches of people having bad redirect URI matching policies, or clients being able to inject redirect URIs into the system because OAuth also allows that, or clients being able to register a million different redirect URIs and share their client ID across all of them because they're really a million different clients, but the developer was lazy and didn't want to register all of the different ones, so they just kept adding redirect URIs. All right, who's done that? All right, only me? Okay, yeah. Also, because it's a front channel, it is inherently phishable. This is a URL that you're handing to a person that you're asking them to go do things. That means that this is a built-in attack vector. Some of that was considered in the design of the OAuth protocol. We kind of assumed this, but it turns out that it's a lot more exploitable in some interesting ways that we didn't predict. So, and this is one of the more interesting subtle ones, is that the HTTP referrer header leaks all kinds of information in the front channel that people never intended. The referrer header is meant to say, like, this is the page that I came from, and here's its URL, except that when you're on the front channel, everything's on the URL, and that the URL of the page that you just came from may have some very sensitive security parameters like authorization codes or access tokens or all sorts of other fun stuff that you don't want in referrer headers being handed to other pages or other servers. Because HTTP was never meant to do front channel style communication. It's a hack, it's a powerful hack, but it's led to some really interesting leaks of things. And this makes it also really difficult to have proper error control. So if you have a page that, if you have something that goes wrong and you need to have an error, do you hand that error back to the client, or do you just throw up Justin Bieber and say, sorry? This is an active debate in the security community right now, what the best practice is in different situations. OAuth really didn't do a very good job of codifying what the appropriate UI and UX were for that. If you saw Nishant's talk earlier this morning, you can see how important UX and good UI really, really, really are to these type of experiences, especially when you're having a user in the security process. OAuth couldn't really specify the server page shall look like this and have these buttons and whatnot, but we did a really, really bad job even capturing what good practice was at the time, let alone really encoding anything that's been done since then in this space. So let's talk about the state parameter while we're on the front channel. And the state parameter allows you to stop a whole bunch of attacks on the front channel in OAuth, but it was made optional because everybody said, wow, it's really complicated to keep state in an OAuth application, so sometimes I'm just going to not do that and everything's going to be fine. Turns out that in practice, state's really not hard to do in basically any application that you care about. And if you don't do it, you are wide open to an entire category of very easily defeatable injection and impersonation attacks that are all based around modifying stuff that's going on in the front channel. Then we get to OpenID Connect, and they wanted to invent another parameter that was kind of like state, but came back in a different way. So not only was state optional, so they couldn't count on that always being used, but it was also narrowly defined as to kind of where it was used and where it came back, and so they invented their nonce parameter. Now the funny thing about a nonce is that it's supposed to be used only once, but it wasn't. You don't actually only have to use it once in OpenID Connect. You can reuse it as many times as you want, so it's not actually a nonce, it's really a state parameter, but that name is taken, and it's just all kind of weird. And then Pixie comes along, few of you get this, and has to invent a whole nother parameter for client verifiers and things like that, that really probably could have used the same kind of structure as before, as either nonce or state or some combination of there, but they couldn't because it needed its own channel because it had to come back in different places. And all of this stuff is really kind of interesting to me right now because in the OAuth world, we have tons of these temporary credentials that are being tossed around. In addition to the ones we just talked about, we've got the authorization code itself. We've got UMA's permissions ticket, which is kind of like an authorization code, but not really like an authorization code. The device flow has its own things. SIBA invented this authentication request ID, which is also kind of like the open banking and FAPI intent ID. And there's all of these things that I think that there's some underlying singularity that all of these things are getting different dimensional views of. I think that in the future we may have some type of grand unified theory of temporary credentials. It hasn't surfaced yet, but it's something that I think is going to be really interesting to watch. So speaking of the front channel, let's talk about the implicit flow, which was designed for in-browser clients to only use the front channel. Now, this is the most important thing about it is that the client is always supposed to be completely inside the browser. Developers saw the OAuth protocol and they said, well, this is OAuth and it's really simple, so therefore it must be secure and I'm going to do this instead and I'm going to use this on my native apps and my web apps and all of this other thing. You see the implicit flow all over the place. It was never intended to be used in those spaces because the Sorry, I lost my train of thought. The assumptions that were made when designing the implicit flow are all about building inside of a browser. Even then, those things kind of fall apart in the real world because the hash is now passed back to the server in some cases, thank you, Google, and it's also passed around between redirects, between pages, thank you, Mozilla, neither of which was true back in 2010. So, the whole problem with people using this incorrectly is the topic of my most read blog post by an order of magnitude. That's how bad this problem is. People are using this all the time, and they shouldn't be because they don't understand why it's a really bad idea. So I really think the implicit flow should come with a warning these days. We really shouldn't be using it. There are better ways to accomplish the same things in SPAs, and there are better technologies today to handle this kind of stuff. So speaking of bad ideas, let's talk about the resource owner password flow. The whole idea is that you steal the password from the user and you trade it for an OAuth token. You might be asking yourself, what on earth were we thinking? The idea, including that in OAuth, the idea was to put it in as a stepping stone to allow legacy applications to come on board into the OAuth world. But the thing is, people saw that stepping stone and set up their house there, which you're really not supposed to do to a stepping stone, believe it or not. And so this is another one where developers saw even all the warnings that we said, you know, this is a really, really bad idea, and like, I'm just going to go for that anyway because I'm smarter than the security community and I'm sure I can do it right. And it's security anyway because it's in OAuth, so it must be good. So this is another thing that needs to come with even stronger labels than the implicit flow. But once again, even warning developers, it might be a noble but ultimately futile battle. So let's talk about TLS. The whole idea with OAuth2 is that it got away from the per message signatures and it relied on TLS for transport encryption in between points. But again, think of what the world looked like back then. You go from one server to another server and you've got a direct connection from an app to an app and everything was kind of nice and well contained. What's the first thing that you hit when you make a TLS connection today? You're going to hit a TLS terminator. That is going to be the first thing that it has, and it's going to strip off all of the TLS stuff, maybe jam some of it into headers and chuck it back to your services. You've also got this entire problem of the front channel, which this problem has been here from the start because instead of making a TLS connection between two endpoints, you're chucking things through an inherently untrusted third party, the browser, which can view and manipulate anything that goes through, which is why OpenID Connect has invented all sorts of things to add on top of the OAuth protocol in order to do signed messages forward and backward using Jose, and it's adding a lot of complexity just because we wanted to use this in interesting ways. This also falls apart, this whole notion of TLS protects everything falls apart when you need to go look up records. If you're in the financial or healthcare spaces, being able to audit transactions, very clearly mark things from one point to another, you have to add other stuff on top of it now. There's no longer an inherent part of the security protocol that allows you to audit. This is the thing that happened with these parties. So let's talk about scopes. Scopes are an innovation that was added in OAuth2 that allows you to ask for specific sets of an API. There's a few problems with scopes. One, that they are completely optional in OAuth2, whether you're giving them or sending them or asking for them or tying them to a token. And so there's a lot of variance into how they're implemented, but there's also a lot of variance into what a scope even means. So when I say scope, it could mean something totally different to different people. Is it the kind of thing that I can get? Is it the kind of thing that I can do? Or is it the place that I can go and get stuff? Another big problem with scopes is that we thought we would be able to have APIs where you have, here's everything that you would be allowed to do, and developers were going to be good, and they were going to get only exactly what they wanted and exactly what they needed in order to do what they had. But once again, developers have proved all of our security engineers completely wrong because they said, I can get waffles and mashed potatoes? Awesome! And I don't even know what to make of that. Then there's the problem of audience restriction. People use scopes for audience restriction because this notion of where can I use a token kind of makes sense. Maybe it's a scope. But then you get into some really weird combinatorics of all of these different aspects of what a scope means. And then there's the big question of whose job is it to restrict all of these different things, right? Is it the client for asking it, the resource owner for providing it? What is it that we're really going to be doing here? So this is something that has been actively debated in the OAuth community for years now because SAML got it horribly wrong with the resource and audience parameters. Nobody knows what they mean. And so we're trying to learn from the past, but nobody has a better idea yet, which is really disconcerting. So you might be thinking now, with all of this stuff, what are we supposed to do now? And I'm really not sure what the next step is going to be. I think that we're going to continue to see some interesting additions to OAuth. We're going to see some best practices. And eventually, we are going to see a protocol that replaces the OAuth protocol. And in fact, I have a recommendation for the name for that. Obviously, we're going on from OAuth. The next logical answer is, of course, ZZAuth. And I invite everybody to come to the closing party. I will be playing with ZZAuth and the Love Tokens this year at the closing party. Please come. It's going to be a great time. Thank you very much.
Dude, I can't believe you pulled that off. That was pretty amazing.
Yeah, I ran a little slow, sorry.
No, you're good. So we have 10 minutes. I know you guys need to be getting in and getting out to your next place, but I think we got 5 minutes. We can do questions.
Yeah, let's.
You're ready to go, right?
I can't actually see anything.
All right. Are you mic'd?
All right. Okay.
You should go get mic'd.
All right. Any questions, comments, snide remarks? Something disguised as a question just made to make you look smart. Wow, nothing.
Not one question. Aha! I knew Pete would be Canada.
Good thing. Okay, awesome.
What's the interesting secret discovery work that's going on?
Oh, the discovery work. So authorization server discovery is relatively straightforward because we almost have a notion of what an authorization server is, although Google, with their deployment of we're going to put the auth endpoint here and the token endpoint over there, it's a little fuzzy even, but we've got some interesting work tying that together. The real interesting discovery work is going to be in resource discovery. That's always been a really hard problem, especially if you're trying to do it in a privacy-sensitive way. So say, for example, that I call an endpoint and I don't know whose endpoint it is, but it says in order to get stuff, go talk to this authorization server. I don't know whose data that is, but I go to that authorization server and it's, a single user server. The authorization server is. Well, that mechanical discovery process that is necessary for the protocol to work just told me whose data that was that I'm trying to attack. And so it's those unintended consequences of new functionality that are making automated and mechanized discovery really, really difficult to pull off in a secure and privacy-preserving way. There's some really interesting stuff about returning hash-based directions and stuff like that. And no, I don't mean the blockchain or hash graph or whatever Ping bought last year. But there's some really interesting work that's using crypto to give people sort of the right direction without divulging information and stuff like that. So there's some cool stuff. Some of it's happening in the OAuth working group. Some of it's happening just kind of floating out on the net. It's a hard problem.
All right, last chance. One last,
Yep,
I think
back
I saw a hand there.
Yep.
Any interesting directions coming out of the whole scopes question and all its different aspects?
No. So this is something that the OAuth working group has been debating for years. There are multiple proposals about an audience restriction parameter being pulled out. Some profiles of OAuth have added them or added several of them. And unfortunately, there's not really a good consensus of even the right direction towards solving that. So scopes, don't get me wrong, are an incredible innovation in OAuth2, made it much better than the all or nothing that OAuth1 gave us or that passwords gave us. But it's one of those things, it's like, it's a step in the right direction, but we can go a lot further. I don't know exactly what that is because the biggest problem with scopes is that you need to be able to balance the usability of the scopes for developers trying to implement this, both on the client and the resource server side, as well as the expressiveness of the scope being able to say, I want to do this thing right here and do that. I've seen groups do really, really, really expressive stuff. The Green Button Initiative, for example, they use an entire, they have a query language that their scopes use. And it's functional, but oh my gosh, is that complicated. It is really, really, really nuts.
What was it called again?
Yeah, that was the Green Button Initiative, so it's power usage information in the US. So that's just one example. I've seen basically everything in the wild at this point.
Perfect. All right, thanks everyone. We start again
Awesome.
at 5.
Thank you very much.